Good morning. Today's lecture we will go through unit step, continuous unit step, then ramp and impulse signal, all these three signals. So the reading of today's lecture, Friday, which is page 16 to 21, and Monday, the readings are page 30 to 35, and on Wednesday, there is a due for homework 2. Homework 2 will include problems 116, 120, 121, A, C, E, and 128, A, B. For more information about the homework, go to Canvas assignments, then you will see more details about homework 2. Okay, so let's continue on the input signal or unit step. So there is functions called time shifted unit step signal. So which is basically like u of t minus a. It will be 0 when t less than a, or 1 when t larger than a. So basically, the waveform will look like this. Here is 0, here is 1. But the original unit step, it used to be at 0, at the origin 0. Right now, at the time A. So here is the time A. Then it is 0. Then at time A will be 1. So overall, how can we know? Look what's inside the brackets. Then t minus a equals 0, therefore t equal a. So at points t equal a, it will be it will start to be from 0 to 1, or the transition will be from 0 to 1. Okay, let's go to some examples. So this example, plot f of t equals u of t plus 1 plus 2 u of t minus 2. So the first observation that you need to look, there is here multiplied by 2, here's the factor 1. Then the unit step will be when we say t plus 1 equals 0, therefore at t equal negative 1, this one will be activated, while for t negative 1 it will be 0. Then for this part, t minus 2 will be 0, so at t equal 2 it will be activated. Then in order to plot this, let's try to plot each term alone, then we will sum them together. So here is a plot. This is for first term, second term, then their sum. Okay, so let's start with ut plus 1. So with u of t plus 1, we said at t negative 1. So here is t negative 1, then it will be 0 before t negative 1, then it will be 1 at this time. After that, the other one, which is u of t minus 2, about times 2. So keep in mind here, it's times 1. Now times 2, it will be updated at t equal 2. Then it will be 2 because it is 2 u of t minus 2. Then it will be 0 like this. Okay? Now we need to do their sum. After we're done with each term, let's do the sum. In order to do the sum, let's draw the guidelines. Here's the guideline at 2, the guideline at negative 1 and at 2. So before negative 1, 0 plus 0 equals to 0. Therefore, it will be 0. Then between negative 1 to 2, it is 1 plus 0, which is 1. So it will be 1 during this period. So here again, this is negative 1, this is 2. Then after 2, we see like with u of t plus 1, there's 1. Then with the second term, 2 u of t minus 2, there's 2. So 1 plus 2 equals to 3. So it will go up to 3, then continue. This is 2. Okay? And this is the plot of 50. Okay, does this make sense? Basically, the first thing you need to make sure what are the weights. So the weights, one of them 1, one of them 2. Then the other thing, which is you need to locate where z of t will be transition or will be activated. Okay, any question? Sorry. Let's be careful what's going on. Anyway, any question about this? Yes?
What is at the top? Is that plus 2 times 4?
Yes, plus 2. Here?
Yeah.
Yeah, plus 2.
Thank you.
Then we can plot any u of t like this way. So put the constants, or try to make each term, and look at when will it be activated. Let's go to another example. Provide the formula for f of t using the step signal representation. Using step signal representation. So basically, I'm going to assume the plot is given. Here is t. This is f of t. Then f of t is given, as shown here, like this way. Such that this is 1, this is 4, and this is equals to 2. Okay. Now the plot is given. I need to find the function or the formula that can provide this, give this output or give this signal. And I need to use u of t. So by looking at this, let's try to think about it. So we need, in order to make u of t, let's look at t equal 1, there will be some action. That action means switch on. So if we can make switch on at t equal 1 second, and we need to have the magnitude 2, so with magnitude 2. How can I represent this? The magnitude 2 and u of t minus 1. That's how I represent this. Why u of t minus 1? Because make it t equal 1, then it will be activated at 1 second, and with times 2. Okay? The next thing, which is at 4, there will be some action like switch off. And that action happened at t equal 4. So it will be like u of t plus, minus 4. U of t minus 4, because between brackets t minus 4 equals 0, therefore t will be 4. But the thing is, what's the magnitude will be? If I make it 2, this will be 2 plus 2, 4.
Negative 2.
Negative 2, exactly. So with magnitude negative 2, to cancel the effect of the other one. So negative 2. Then the overall will be f of t equals to 2 u of t minus 1 minus 2 u of t minus 4. That's it. Okay? How can I prove this using the waveforms? I can assume like, I suppose. Here's t, t, t. So again, we have the function like this. And here's 2, here's 1, here's 4. 4, 1, 4. So the first thing I need to make is, which is activated at 1, like this, with magnitude 2, while the other one activated at 4, with magnitude -2. Then when you sum them together, you will end up having this result. Okay, because 2 and -2 will cancel each other. So you can do it either in the waveform way, or you can do it in the equation like what we did before. So it's up to you. Okay? Now let's go to another type of signals, it's called ramp signal. Let me hold on a few seconds so you can write. And then we'll go. Restart. Ramp signal. So ramp signal, basically we denoted it by R of t. And R of t is actually, it is t u of t. It's very related to u of t, but we will multiply by t. So what's the point of this? The equation will look like this one. So it will be z when t less than 0, t when t larger than 0. So instead of activating t as a unit step as 1 from 0 to 1, now it will be activated to be as a linear waveform. So here is the time. Then in order to make R of t, it will be 0 when t less than 0, or it will be 1, or it will be t. So here is R of t, like this. While the step, it used to be like this, but the ramp will be like this. Okay? And the same thing for shifted ramp. So when we make a shifted, we will shift where it will be started. So I will say that we can have R of t minus tau. This will be 0 when t less than tau, or it will be t minus tau when t larger than tau. So if we assume, for example, tau as a positive number, then, for example, tau will be here, and it will be 0 before tau, and it will start like this. So it will be called t minus tau. So again, how can we make sure where is the location of the startup? Look what's inside the brackets, t minus tau. So make t minus tau equal 0. Therefore, it will start at t equal tau. And the slope every time comes with 1. Unless it's multiplied by a function, then the slope will be different. And there is a result about this. So again, R of t equals t u of t. Therefore, u of t is actually the change, delta R of t over delta t, or in other words, the time derivative, dr of t by dt. So the time derivative, because make the derivative, try to derive dr of t by dt, so which is the derivative of t will be 1, then we end up having u of t, while the derivative of u of t can be 0, then the only thing we will have only u of t. Okay? Is the derivative of 1 times the other plus the derivative of the other times 1, and we will end up having this. So the ramp is a special function similar to u of t, but the difference is it has a slope and it goes as a linear curve. Okay? Let's do an example. So provide the formula for y of t using two things. The first thing based on u of t, the second approach based on r of t. Let me do the plot. So here is the waveform, then it will be here's 0, and it goes like this way, and then back, like this. So this is 0, this is 2, and here is 1, the magnitude of 1, this is y of t. So when you have these kind of questions, I encourage you first to try to find the equations, the original equations, then you can convert this to r of t or u of t. How? You will see this graph is plot, or this segment has two segments, like this approach, then or this and this thing, or even like this one. Let me do it again. We have this region 1, when it is 0. We have region 2, when it starts increasing. We have region 3, when it starts decreasing, and we have region 4, when it goes to 0. Region 1 and 4, they are well known, 0, 0. So when t less than 0, it is 0. When t larger than 2, it is 0. So that's well known. Now the other thing that we need to figure out, which is region 2 and 3. How can I know region 2 and region 3? Basically, this is linear waveform. And we know the linear equation, which is you need to find the slope and the linear equation. So let me just write something. So for region 1, R1, it is 0 when t less than 0. Region 4, it is 0 when t larger than 2. Now we need to work on region 2. In region 2, let's work to find the slope. Let me just write some formulas for you and to remind you with the slope. So slope equals y of t1 minus y of t0 over t1 minus t0. And the linear equation, like y of t minus y of t0 equals the slope times t minus t0, something like this. This is from mathematics, which is how to find the linear equation or how to find the slope. So in region 2, let's find the slope. So I'm going to call it as S2, as a slope region 2, which is y of 1 minus y of 0 over 1 minus 0. Y of 1 is 1, according to the graph is 1. Y of 0 is 0 over 1 minus 0, so the slope is 1. Then, in order to find the equation, so it will be y of t minus y of 0 equals slope of 2 minus or times t minus 0. So y of 0 equal to 0, therefore y of t will equal to t. And this region R2 only between 0, t, 1. The other thing, let's find R3. For R3, the same thing, we need to calculate the slope, but keep in mind the time interval. So in region 3, we have 2 and 1. We will no longer say 1 and 0, now we have 2 and 1. So S3 will be y of y of 2 minus y of 1 over 2 minus 1. So y of 2 equal to 0, y of 1 equal to 1, then over 2 minus 1 over 1. So the slope will be negative 1. And according to the equation, y of t minus y of 1 equals to slope, or S3, that's what I call here slope, t minus 1. So let's substitute them. Y of t minus y of 1 is 1, equal to the slope negative 1 times t negative 1. So this will be negative t plus 1, then move 1 to the other side. So y of t will be negative t plus 2, or in other words, we used to write it like 2 minus t. and this only between 1, t, 2. Okay? Between the term. It's just like mathematics, this is calculus, something like that. So, how to find the equations. Now, after we find all of these 4 intervals, let's write the overall equation in 1. Okay, so we have region 1, 2, 3, 4. Therefore, y of t will be 0, according to our analysis, when t less than 0, or it will be t when t between 1 to 2, or 2 minus t when t between 2, t, actually 0. It's between 0 to 1, here between 1 to 2. Then it will back to 0 when t larger than 2. Okay? How can we manipulate this as a step or as a run? Okay, in order to manipulate this as a step or as a round, what matters with us? Only these 2. While the rest are zeros. So, in order to manipulate the first one, so this one, it will start to be t at t equals 0. So, we will say in t times u of t. Okay? Because it start to be t at u of 0. Then the other thing, it will go back to 0 at t equal 1. So, minus t u of t minus 1. Okay? T is a factor. Now we have u of t. It will start from t equals 0, then go back to 0 at t equal 1. Or in other words, we will say t as a factor, u of t minus u of t minus 1. Such that this is the on time, this is the off time. It is on at t equals 0, it's off at t equal 1 with this one. Okay? Any questions? So far so good? The next thing is to do the 2 minus t. Look at the intervals. It will be activated at t equal 1. So therefore, we have a factor 2 minus t as a factor. Now, it will be activated at t u of t minus 1. That's the activation time. Subtract the off. So it will be on minus off. It will be off at u of t minus 2. Okay? On minus off. Therefore, I will say the overall function y of t is actually adding these 2 equations. So it will be t u of t minus u of t minus 1, then plus 2 minus t u of t minus 1 minus u of t minus 2. Okay? Does this make sense? So this is the representation, the first representation based on u of t. Now the next representation is based on r of t. Based on r of t. In order to recall this, let's make the plots. Actually, when we make it based on r of t, it will be easier in this situation. So here it is 0. And 0, here is 1, this is 2, this is 2, and here, this is 0. So, when we look at this regions, it's divided into 4 regions. Let's look at region 2 and 3. So, which is basically we need to look here and let's look between 0 to 1. Between 0 to 1, what's the slope that we calculate? We calculate the slope, which is 1, here actually 2, minus, it's actually 1. The slope is 1 minus 0 over 1 minus 0, so the slope is 1. And there is no time shifts, so it will be R of t. This part, between 1 to 2, now, if we need to cancel the effects, we will put minus R of t alone, R of t minus 1. But our target is not only to cancel the effects, we would like to make it go down. So what do I mean by this? If I make it as minus R of t, it will look like this, minus R of t, it will be 0. So the slope will cancel each other. But overall, it will go down. Or, I will say, look at the slope. The slope here is 1 minus 0 minus 1 over 1 minus 0, so the slope negative 1. Okay. So, we would like to make R is negative. So it should be negative R of t minus 1. But again, if we make it only R of t alone minus 1 without R, another factor, this will make the slope 0. Because 1 plus minus 1 will be 0. So it will look like this and like this. But our target is not, we don't want the slope to go straight, we want to go down. Therefore, we will multiply by 2. So, in order to overcome this, we will make it negative 2. So, we have R of t, then negative 2 R of t. Now, the other concern, what will happen after t equal 2? We need to cancel the effect of the slope. So basically, to cancel the effects, we will make another plus R of t minus 2. Always plus. So the overall y of t will be R of t minus 2, R of t negative minus 1, plus R of t minus 2. How can I validate this? Let's validate it here. Y of t equal R of t minus 2 R of t minus 1 plus R of t minus 2. So R of t will continue like this. Minus 2 R is R of t. Minus 2 R of t minus 1. Let me put the different color. So here is 1, t equal 1. Then it will go like this with slope negative 2. While that one is the slope plus 1. Then the last thing, which is plus R of t equal 1, which is at t equal 2, it will go up with slope equal 1. So if we need to plot everything, and this one, and write it R of t minus 2, if we need to plot everything by making the sum, let's do the intervals. So we have here, here's the guideline. This is F1. This is F2. And this slope Okay, let's see, let's make sure everything's all right, so. So the overall, you need to look at the slope. So here is 1, here is 2. When t less than 0 during this region, we need to complete and this region 0, 0, 0, so everything is 0. Now, in this region, we have slope is 1 and the rest are zeros, so it will go up with slope 1 until reaching like 1. And the other region, slope is 1. Slope is negative 2. So 1 plus negative 2, negative 1, right? So the slope will be negative 2, negative 1. Then, in the last region, slope is 1, then plus slope is negative 2, negative 1. Then for the r of t minus 1, which is the slope is 1, then overall will be 0, because the slope 1 minus 2 plus 1 will make it 0. That's the slope. While the slope here is 1 minus 2, this will be negative 1. Here the slope here is 1. So the overall slope will be 0, and that's how it is. Okay? Any question? Yes.
So I'm a little confused on that last part. To cancel that signal and make it go back to 0,
Yes.
why wouldn't you just add the 2 to cancel the previous signal? Why does that have to cancel the whole thing?
Which part?
Because if you go up to the top to the original signal,
Yeah.
so you have r of t,
Yes.
you're subtracting 2r, so that gives that negative 1. So to cancel that negative 1 slope, wouldn't you just add the 2 instead of 1?
Yeah, if you add the 2 instead of 1, the overall slope will be 1.
It'll still go back up.
So it will go up, back up.
Okay.
Yeah, so you can look at it, look at the factors here, the negative. So the factor here is 1, the factor here is negative 2, the factor here is 1. So 1 minus 2 plus 1 will be 0.
So the more different changes the signal you have, the more you have to cancel the whole thing.
Yes.
Okay.
Any other question? Okay, so again, make sure you like to practice on this, because as I said earlier, this course is not easy, but if you understand this, it will be great. It will make it easier for you, more comfortable. Now, how we can manipulate this using MATLAB. So let's discuss a little bit about MATLAB. So in MATLAB, if we need to plot, to do the command u of t minus t, there is no function it's called u of t in MATLAB. We need to define it. In order to define it, we will write function y equal u of t to, like this. So we will define it by ourselves. It's not really defined. Okay, so what's y? Y will be t larger or equal to to, then 3 brackets. That's what we will write in the function. Then we will save it in an file, separated M file. We call it u of t minus t0. That's what we will write in the M file. M file, that's called u of t, t0. Something like that. I mean, you will store it, so you can save it. Then you will realize this function, or the code related to this. That's the original code. this is larger or equal to t, so which is based on logic, 0 or 1, or some people like truth table, or binary. So the output of it, the expected output will be 0 or 1. And that's actually what's the output supposed to be for the unit step. It can be 0 or 1, right? And if we need to make it unit step of 2, just multiply by 2, something like that. So if I mention, or if I write y in the commands, y of t, or y equal u of t larger than 1. So the output, this means at t equal 2, while my TO is 1. This looks like u of t minus 1, and I substitute t equal 2. So here u of t minus 1, like this, and my target at 2. So at 2, of course, is going to be 1, right? So the output must be 1. U of t, u of 2 minus 1. So of course the output will be 1. So how is the MATLAB will manipulate this? It will manipulate it as, will substitute it as y of y equal to, is 2 larger than 1? Then yes. So the output will be 1, which is true. How about if I did in the MATLAB like y equal u of 1, 2? So 1 is less than 2, or actually, so I have the unit step starts at 2, while my output is at 1. So at 1 there is nothing. So there is 0. Okay? So my observation at 1. Then at 1 everything is 0, so therefore it must be 0. Then what will happen? What's the MATLAB understand this? It will understand it as, is 1 larger or equal to 2? 0. It's false. False will make it, we'll write it as 0. So basically this simple command or this simple function can do the job for u of t. That's how the MATLAB will understand. How about the RAM, R of t? R of t, as we know, it is t u of t. So we can define as a function y equal r of t, to. Therefore, we will write as y equal to t times, instead of u of t, as we know u of t is t larger or equal to t. Then that's how we define it, such that this is equivalent to u of t. So that's what we'll write in the MATLAB. These two are fine, then you can define the R of t as well. Okay? Does this make sense? I'm going to show you some MATLAB scripts. So here, that's how, again, we define u of t, y equal u of t minus to. That's the command that I wrote. Then, if we need to define r of t, like this way. Actually, I forgot to mention, since it is u t minus t. That's my mistake. And then here, t minus to times t larger than t. And keep in mind, we use this product. There's dot, then there's multiplication. This means if your input data as a matrix, then you are multiplying elements by elements. So whenever you see dots, then this dot means this multiplication is not a matrix multiplication, but it is element by element multiplication. This is just a MATLAB. Now here's an example. If we need to plot R of t or u of t, whatever we need to plot, then that's how we do. So we have t equal to 0 with step size 10. Then we can plot by the function. So here, basically, as I told you last lecture, this is the time step. So if you need to plot from 0 to 10, you can write it. If you need to plot from -1 to 1, whatever the plotting rate, you will decide it here. Then point 1 is the step size. So if you need to increase the step size, you can, or if you need to get better accuracy, reduce the step size. Yes?
I'm getting an error where I can't name the function u. I have to name it the name of my file.
Yes, the function, let's see, I think you need to put this in the M file, all of them. You can put them all of them in the same M file.
It's in the same, it's in the M file.
Is it in the same M file? Okay, can we discuss this after class? Okay, then when we do this, you can make the plot range, then we can get this plots. Sometimes you see the plots, we cannot see this region, so you can make the axis and make identification on the axis or the x limits or y limits to change, so you can be able to see the other type of plots. So basically, there's an advanced version. I make an axis here, so this is related to x-axis, up, lower, x-axis, x low, x up, and then this is y low, this is y up. So by adding this command, you will get better image, which is this waveform better than that, because we are not able to see what's happening here. It's in the limit, but when we make axis, then you can play with the view. That's the problem. Okay. Now, another thing. Okay. Any question about that? Let's go to another function. It's called rectangular. Rectangular pulse. So basically, rectangular pulse, the standard format of it is like this. So here 1, it's in the middle so that it's centered at 0. Then here, tau over 2. Here, negative tau over 2. This is the time. So basically, we will say it is P of t at tau. So it's overall 0 when t less than tau over 2, or 1 when t between negative tau over 2, t to tau over 2, or it can be 0 when t larger than tau over 2, or in other words, sometimes we will call it as rect t over tau. So whenever you see the word rect t over tau, we mean this is pulse. And basically, it is centered. So t over tau, tau will tell you what are the period. Because the period here, from here to here, is tau. Or we call it the time overall. It's not exactly period, but overall width, the pulse width. Okay? And if we want to do it, right, if you want to write this in the step function, it will look like this. Rate of t will be u of t plus tau over 2 minus u of t minus tau over 2. This is also the rate function. How can we deal with the rect function, like overall general, like representation? It can be as it can be as a times rect t minus t1 over t2 minus t0. This is overall expression. Okay, how can we understand this thing? So basically, this is for the amplitude. This is for the center. Center at t minus t1 equals 0, therefore t will be t1. And this is related to the pulse width. So the pulse width will be t2 minus t0. Okay. So let's do a small plot. Here is, let me say this is T0, this is T1, this is T2, and it is 0 for than that, then it will look like this way here. So you will realize it is centered at T1. That's why it's T minus T1 equals 0. That's why the first part. And the pulse width T2 minus T0. Okay? Let me give you an example about the ricts, which is plot or let me say write the function. Write the formula of this thing. So here is 1, here is 2, here is 3. So we will realize that also like the magnitude is negative 1. We realize that since the magnitude is 1, it will be, or the function will be negative 1, then there is ricts. What's inside the ricts? It is centered at 2, so t minus 2. Then the range, 3 minus 1. Upper minus lower. So the overall will be negative ricts of t minus 2 over 2. Or actually, yeah, t minus 2 over 2, yes. If we need to do this presentation into exponential or into what's called unit step, it will be, you can try it at home, it will be u of t minus 1 plus u of t minus 3. You can try it and see. Any question about rict? Okay, let's start here a few minutes late, but let's start about the impulse function. Start with the impulse function, then we can continue with this also. So, impulse function or impulse signal, it has different properties. So we used to denote this by a Greek letter which is delta. We know the Greek letter for delta, there is uppercase and lowercase. There is lowercase like this, there is delta uppercase. So impulse function most likely will use the lowercase. So we will call it as delta. Okay, what's the properties? Basically, delta of t, or since we discussed late before, u of t equal to the time derivative of ram r of t by dt, we will denote delta of t is the time derivative of u of t. And since it's the time derivative, it's going to be instantaneous, something like this. This is how the delta t. Delta t. We will put an arrow. And actually, delta of t is something we cannot know the value of delta of t itself exactly. What's the value of delta of t? Because this arrow goes forever, goes to the infinity. But actually, we know the area of the delta of t. So we know if we do the integral between here to here, then we know the area will be 1. But the thing that we don't know, which is what's the value itself. Because the integral is the opposites of the differentiation. So the integral of the differentiation will cancel each other, it looks like u of t. When you do the integral, it looks like u of t. But when you do the derivative, no. But how can this be useful? We are using this when we multiply with different functions. So here it's this arrow centered at 0. But when I say delta t minus tau, so basically you will say t minus tau equals 0, so it will be centered at tau. Then I will say it will be here. This is tau, then here is delta t minus tau. Okay, so this delta of t has different properties, has multiple properties. Delta of t has properties. And these properties that will make it useful. Without these properties, this will not be useful at all. One property, delta of t equals 0 for all values that does not equal to 0. So delta of t at other than t equals 0, it will be 0. While at t equals 0 exactly, we don't know what it is. Or actually it will go straight to infinity. And the second property, the integration, delta of t between negative infinity to infinity, dt will be 1. Because if we do the integration, the overall area for it will be 1. Or we will say that between negative 0.5 to 0.5, or any small number, delta of t, dt will be 1. So it's not only between negative infinity to infinity. My target is to make the boundary between negative 1 to 1. While if I do, this is the last thing, between, for example, 1 to 2, delta of t, dt, this will be 0. Why? Because my delta of t is centered as 0. But when I do my integration between 1 to 2, then I'm integrating nothing, like integration of this thing. Okay? Does this make sense? We will continue next lecture about delta of t. We have different problems.